All right, guys, so what we're looking at here is an example from 2021 of particular solutions. This one, again, fairly straightforward. There's a couple slightly strange things, and we'll get to those when we get to them, but let's just jump right in and look at this problem. So the initial problem says a medication is administered to a patient. The amount of milligrams of the medication in the patient at time t is modeled by some function that we don't know and satisfies the equation right here, so I'm basically given the derivative. Okay, at time equals 0, there are 0 milligrams of medication in the patient. So this tells us basically how fast the medication is entering into the patient, and that's what the derivative tells us. So we look at letter A, and it says a portion of the slope field for this is given below. Sketch the solution through the point 0, 0. So it's basically saying, I know my solution goes through 0, 0. What's it going to look like? And we more or less just follow the slope field until we get to this nice horizontal asymptote, and that's it. That's your answer to letter A. Letter B says, using correct units, interpret the statement, the limit as t approaches infinity of A of t equals 12. Well, basically what that's saying is, as time goes forward, and there's no other way to really say it other than understand what's going on here, the amount in milligrams, because that's what A of t is measured in, of the medication is going towards 12, is approaching 12. Because that's really what it's saying here. That's always what a limit is. So we're saying that this is approaching 12. That's it. That's all you have to say. You got milligrams. Time moves forward. I mean, you could say time in hours, but you don't really have to say that. We just have to make sure we get the milligrams right for the fact that the medication is going towards 12 milligrams. Letter C says, use separation of variables to find the original function. Now remember, the y's always have to go to one side, and the x's always have to go to the other, and we don't really have a say in which side they're going to. The y's always go to the left-hand side, the x's always go to the right. In this case, they're t's, and there are none in our example, in our problem, which makes it a little bit more difficult until we realize I just moved this 12 minus y over to the other side. That leaves a 3 on the bottom, and I can take care of it like that. Then I'm going to take the antiderivative of both sides, so I get the ln of 12 minus y is equal to 1/3 t plus c. So now I took the antiderivative of both sides. Now I plug in my initial condition. So I get the ln of 12 is equal to 1/3 times 0, which is 0. So c is equal to the ln of 12. So now I have the ln of 12 minus y is equal to 1/3 t plus the ln of 12. The last thing we need to do in this problem is get the y all by itself. So I need to get rid of this ln. So I'm going to have 12 minus y is equal to e raised to all of that stuff right there. Now to get the y by itself, I'm just going to minus 12. So I'm going to have negative 12 minus e to the 1/3 t plus the ln of 3. Then lastly, oops, that's plus, not minus. And lastly, I'm going to divide by negative 1 to get that y by itself. And that is the correct answer to letter C. Again, hopefully that one made sense. Not too bad. Letter D says, oh, we have a new function where different procedures used to administer medication to another patient. So this is a different patient with a different rate at which it's being administered. It says at time equals 1 hour, there were 2.5 milligrams of medication in the second patient. Is the rate of change in the second patient increasing or decreasing? In other words, is the second derivative positive or negative? I want to know, is the derivative changing? So I have to take the derivative of this. So the derivative of 3 is 0. So I get d squared y over dt squared is equal to 0 minus, then I have to take the derivative of this using the quotient rule. So that's the bottom times the derivative of the top. Now remember, y is our dependent variable here. So when I take the derivative of that, I get dy dt minus what's on top times the derivative of the bottom, which is just 1, all over the bottom squared, which is t plus 2. dy dt, this dy dt right here, is the dy dt that's right there. So when I evaluate that, now I have to plug in 1 and 2.5, I'm just going to use this formula right here. So I get negative 1 plus 2, and then I'm going to have 3 minus 2.5 divided by 1 plus 2. So that's 3 minus 2.5 divided by 3. If I get a common denominator here, that would be 9. And I need to know what the number is. That's why I'm getting a common denominator. So I get 9 minus 2.5, which is 6.5 over 3. So I've got this right here is 6.5 over 3. Minus, my y value again is 2.5, divided by 1 plus 2. What I care about is whether this number is positive or negative. So all I need to know is this number right here, that's 3 times a number bigger than 1, is going to be bigger than 2.5. So my fraction here in general is going to be a positive number, and that times a negative out front, which means it's negative overall. So that means that it is, the rate, is decreasing at that particular time. And your reason is the second derivative is negative, so you don't have to say much more than that. Hopefully that problem kind of made sense. I felt like A, B, and C on that were fairly easy. D was a little bit tougher. So if you have any questions about that one, please let me know.